Hello, everyone. I'm Sanathan, and I'll be talking about, just a second. Please. So my name is Sanathan, and I'll be talking about, so this is in perspective to a data engineer, right? Like with perspectives to data engineer or data science. And because the title, as you have mentioned, is predictive analytics. Okay, so should I frame it for data science or data engineering? That's what I'm confused here. Charissa, are you there? Yes,
Charissa, you're there? Okay. So you can go ahead, I guess. With
okay, I'll take care of it. That's okay, I'll take care of it. About me, I've right now I'm in academia. I work with Mahindra Ecole Central, which is under the flagship of Tech Mahindra. The university is called as Mahindra University. Before joining Mahindra, I was at Punjab Engineering College in Chandigarh. Prior to that, I have worked in Amazon, Intel, Siemens, and HCL for a very short period. So with that, my data science career started, and today I'm here in front of you delivering a lecture on data science. Okay, data science and data engineering. Now, see, in our digital era, we all are surrounded by like big e-commerce companies, right? If you think about it, like from your social networking websites to your let's say online some product selling websites, right? Now these are big tech giants, and they all are collecting your data in one form or the other, or you are providing your data to them, right? You upload images, you write tweets, right? You buy products, so then your data gets collected from there. What kind of products are you buying? Now, companies have now realized that they can gain substantial amount of information and insights into how customers think. And what they are trying to do is like they want to analyze this humongous data, which is being generated every year. So if I summarize like what is happening in the industry right now, see, over the last 2 years, the amount of data that we have generated, okay, it's more than what was there prior to 2020. So that is the volume of data that we have today. So most of these companies which are hiring data scientists and data engineers, they are trying to gather as much insights as possible, gather as much information as possible, okay, by doing some kind of scientific analysis on your data. That's why it is called as data science. So there is some scientific procedure, or you can say some science is involved, through which you are able to analyze this data and you gain some meaningful insights. Now you can use these insights, right, to grow your company. So basically, let's say you take some actions which increase, let's say, customer satisfaction, which help in the growth of your profits, right? So, I mean, such opportunities are there. So why not? I mean, we all should, I mean, aspire to be like good data scientists in the coming future, right? Now, let me start with what kind of job opportunities are out there. So primarily, there are 3 kinds of jobs pertaining to like analysis and handling of your data, okay? Now, the first one is called as a data engineer. I'll describe how they differ. The second one is your data scientist. Okay, and the third one is your machine learning engineers. Okay. Now, starting from your data engineers, see, imagine a big company is there. Okay. Let's take the example of, say, Amazon. Okay. So there are millions of customers on Amazon, and they are doing their transactions daily, right? So Amazon is storing the data of the sales, right, of the customers in form of, let's say, invoice receipts for the sellers which are having these their products on their websites, right? Then you have, let's say, customer feedback, the reviews about these products. So you have these different departments. So the idea is like when you have the data in so many different, in so many different departments, and each of these departments is storing your data, let's say in a different file format. Okay, how do you process it to understand, to understand the mindset of a customer, and how do you make use of this information to make your customer buy more from your website? Okay, if I'm thinking in terms of Amazon. Okay, so what should I do so that what should I do from the data which is provided to me? Is there something hidden in it? So can I do something which can lead to, let's say, increase in customer satisfaction, maybe in terms of delivery services? Okay, maybe in terms of let's say giving him more discounts, giving him or her more discounts, right? So how should I assure that the entire flow of customers come to my website instead of going to my competitors? Okay, so that's the main motive behind data analysis. Now, what data engineers do, your data, the data for a particular company could be about, let's say, customers, about sellers. At a point in time, let's say you want to analyze, let's say, the information about the sales data. Okay, now sales data could be with the sales team. It could be with the shipping team. It could be, some portion of it would be with the shipping team. Some portion of it could be, let's say, with the billing team. Some portion would be maybe with the review collection team, right? Now they must be storing the data in different file formats depending on how, what kind of softwares are they using, right? So the thing is that these data engineers, their primary job is to how to handle different types of data, okay, different file formats, and how they can ensure that when they are combining this data, okay, so the data is properly cleaned, it can be properly processed, so that some analysis could be done on it. Okay, that's one of the jobs of your data engineer. In general, if you think about the volume of the data, right? See, the data is humongous, right? It would be in petabytes. Okay, so it cannot be stored on a single device. So data engineers need to know like how to use cloud-based services. Okay, what do you mean by cloud-based services? See, the idea is that, let's say you have a network of devices. Let's say this is computer 1, this is computer 2, computer 3. You can imagine, let's say there is a large number of computers which are connected with each other. Okay, and now let's say this is Amazon. So Amazon is storing all its data on these different computers. Okay, imagine there is a software in between, okay, which lets you which can control. So if you want something from any of these computers, so this software in the middle can help you retrieve this data, okay, can help you upload data to these different systems, okay, can help you manipulate this data as well, okay. And there are certain things, for example, if you think about these computer systems, right, unlike your regular desktops, okay, unlike your regular laptops, where your configuration is fixed, one of the advantages that you get with these computer systems is that they are scalable. So at a particular time, let's say if you are having, let's say, a big sale, so more number of customers will come in, right? So these computer systems, they can increase, you can say, the amount of memory, or increase the amount of, let's say, their storage on the go. Okay, that's what these computer systems can do. Okay, so unlike your regular systems, you can say that they can scale up according to the needs. All right. So the software which stands in the middle, you can presume it to be a cloud-based. Okay, you can say it's a cloud service provider. Let me rather say it. Okay, it's a cloud service provider. You can imagine these computers to be distant from you. You are not directly connected to them, but this software, it gives you the feeling that even though these servers are far away from you, but you can still access them and retrieve or manipulate or update the data on these servers. Okay, so now there are many different providers of these cloud-based services. The most prominent cloud-based service providers are, so one is Amazon itself. So you must have heard of Amazon Web Services, or short form is AWS. You would have heard of at least this abbreviation at least. So Amazon provides its own cloud-based services. Okay. Now, this is used by, I would say, more than 80% of the companies nowadays. Then you have Microsoft Azure. Okay, this is another cloud-based service which people use. So depending on like which company you join, you would see, I would say, either of the two predominantly. In most companies, these two would be deployed. Now, there are some, I would say, not so popular vendors. I mean, they are in their budding phase. They do also provide some cloud-based. So there are some cloud-based startups, I should say. Okay. So, I mean, the companies are also using their products, but these two are the most prominent ones. Okay. So a data engineer needs to know how these cloud-based services work. So he or she needs to understand how to access these cloud systems, I mean, the systems on the cloud, so that the required data can be retrieved. Okay, that's another thing. Now, let's say you have retrieved your data. Okay. So imagine you have retrieved, so as a data engineer, you have retrieved, let's say, some data from a cloud device. Okay. Now you want to store it somewhere, right? See, if you can store it in the raw format also. I'm not saying you cannot store it in that raw format, but nowadays there are some tools available which give you the flexibility of, I would say, doing some analysis on your data directly. Okay. So otherwise you would have to write some kind of high-level language code to do the analysis. Okay. But nowadays there are some tools that you can use directly to do the manipulations or make changes to your data, or maybe, let's say, retrieve a small portion of the data that you retrieved. Okay. So in general, the type of data which you have retrieved could be of two types. Okay. One is called as structured data. One example I could give you is of tables or tabular data. So the data, you can imagine, will be stored in the form of tables, in the form of rows and columns. Okay. It could also be in form of graphs. So graphs are also like common examples of structured data. Okay. Even so, there is you would have heard about let's say HTML and JSON. So these are some popular file formats which are used to store your data. Okay. Simple text files, at least you would have heard of, right? So they come under the category of unstructured data. Okay. Where the content that you're storing, okay, it is not following any structure. Okay. You're just dumping the content. Let's say if the content is of type text, so you can imagine that the text content is just dumped onto, let's say, raw text files. So let's say simple text files, rich text files. Okay. So these could be examples of your unstructured data. Okay. Even I would say HTML and JSON, you can call them as semi-structured data. So they lie somewhere in the middle. Okay. So even though the HTML and JSON are itself, I mean, raw content types, but they still have a structure, right? If you look at a HTML page, they do have some tags, right? And with the help of these tags, you can identify which data is stored in which particular tag, right? So they do have a structure. So that's why I'm calling it as semi-structured. Same is the case with JSON file formats. Okay. So a data engineer needs to be comfortable with these file formats. Okay. Now, see, from the perspective of doing some basic analysis, a data engineer needs to know some visualization libraries. So he or she needs to know some visualization library. So basically, let's say you have the sales data from, say, Amazon. And maybe if I ask you, can you tell me what are the sales of, let's say, iPhone in different states of India? So instead of giving the results in the form of text numbers, I mean, it would be better if you show the results in the form of like visual plots, right? so that, and you can even sort these results, draw beautiful plots to show the comparison between the different states. Let's say if I ask you about, let's say there are 3 different popular brands like iPhone, Samsung, Xiaomi, and you want to compare their sales across India. So I want to show the relative percentages of the 3 different brands. In that case, you would prefer a pie chart, right? So depending on what kind of information is sought, so you can pick the appropriate chart for it and display your results in that particular chart. Okay. All right. Now, what else a data engineer needs to know? See, one thing is that, which I forgot to mention. See, your data comes in different formats, right? Structured and unstructured data. So I told you there are specific tools to handle your structured and unstructured data. So if your data is of tabular type, basically you have tables. So there are certain tools which are used to handle structured data. So let me just say for tabular data. Okay. So these tools are called as relational database management systems. Okay. Let me open up the chat window. In case if you have any questions, you can. Yeah, sorry. In case if you have any questions, you can write to me. Okay. So these tools are called as relational database management systems. Now, some of the relational database management systems, they are free. I mean, they are open source. So you can also install it on your device and work with them. Some of them are proprietary and some of them charge you some money. So you need to have a license if you want to use them. Okay. Nowadays, most companies use open source and I would say free softwares. Okay. So one of the popular softwares is called as MySQL. Okay. So with this software, what you can do is that, let me just put it very simply. Okay. I know most of the audience is a beginner. So what this software can do is that, let's say I give you multiple tables. Okay. Now there can be infinite number of tables, I mean, some countable number of tables, let's say. So let's say you have downloaded these tables onto your device. Okay. If I ask you to retrieve, let's say these 2 columns of your, let's say table I and table J. What you need to know is like how to work with this. I mean, so this MySQL tool can store your tables. Okay, as a software, it can help you store your tables. Okay, so it gives you an efficient way of storing these tables. Okay, it also gives you an efficient way of retrieving the data from your tables. So there is a language, you can say there is there are some instructions that you can write. So if you want to retrieve, let's say 2 specific columns from 2 different tables, what you can do is you can write some English-like instructions, and this software will retrieve these 2 columns for you. Okay. You don't have to write or you don't have to scan these 2 tables manually. Okay. And then retrieve these columns. Okay. So you can call it, let's say, a program also. Instead of calling it a program, rather I would say that it is either single or double line instructions. You don't have to write a big program for it. You just need to write maybe 1 or 2 English-like sentences. Okay, we will talk about it. I'll show you how to do it. Okay, we do have some 15 to 20 minutes reserved for this. Okay, and the language, the English-like language that you use, okay, to work with this software is called as SQL. That is why the name MySQL. Okay, I hope you get the relationship. Okay, so SQL is called as structured query language. Okay, it is called as structured query language. This language can, so if I summarize, this language can, let me say, retrieve. So if you simply want to retrieve some information from one table or multiple tables, or if you want to combine multiple tables also, this language can help you do it. Okay. If you want to manipulate your data, so basically edit, add, delete, update. Okay. So one question is being asked, whether this, so Postgres SQL, okay, this is another software like MySQL. I hope this is the answer to your question. Okay, so this is another software like MySQL. Okay, this software also uses SQL as its way to talk to the tables. Is that part clear? So SQL is the language. MySQL is the software on which this language runs. Okay. Similarly, Postgres SQL, you can say it's a tool or a software on which SQL learns. Okay. Right? Okay. So you can manipulate. So basically, you can do add, delete, okay, say update. So you can update any specific value in any of these tables. Okay. Now you can obviously join many tables. So you can do a lot of these operations pertaining to tabular data. Okay. So this is for your structured data. Now there are tools to handle graphical data as well. Okay. So depending on what type of structured data that you have, okay, you will be taught a set of tools which can handle those type of structured data. Okay. Now the second thing is for unstructured data. See, in general, most of the content of these e-commerce giants is stored in either HTML or JSON, predominantly, I should say, or it could be in raw text files. So there is this tool which is called as MongoDB. So Purvi is asking which RDBMS software is most preferred in the industry. So Purvi, let me put it this way. See, if some professionals are working, let's say, yes, Naveen. So Informatica is another tool on which you can run SQL. Okay, so I would say Informatica is one of those tools which is most popular. Okay, but Informatica has a lot of other things. It is not just a RDBMS tool. Okay, you can do a lot of these things on Informatica. Okay. Oracle RDBMS is a structured data handling tool. Okay, I should rather skip your questions. I mean, you'll keep on asking. Okay, all right. Okay, let me move on to the next topic. Okay, but anyways, if I find a relevant question, I'll try to respond. Okay, sir, by HTML, do you mean XML also? See, HTML is a hypertext markup language, the web pages that you use on your websites. Okay, XML is for storing your data, right? So yeah, you can always induce XML on an HTML web page. I'm not denying that. But yes, you can store XML documents here as well. You can think about handling XML documents. Okay. So to handle your unstructured data, or let me put it like semi-structured data. Okay. So to handle your unstructured or semi-structured data, we have this tool called as MongoDB. Okay. And this MongoDB can do like the same things, but it does it on unstructured data. So let's say raw text files, raw HTML files, raw JSON files, raw XML files. Okay, it can do it. All right. And the language which it uses, okay, the language which runs on this MongoDB is called as NoSQL. See, such a non-fancy name. So it's not a SQL language. It's different from your SQL. Okay. So we'll teach you the syntax also in the main bootcamp. Okay. But the idea is now you can work with unstructured or semi-structured data as well. Okay. So that's another job of data engineer. Now, what else a data engineer needs to learn? See, now there are so many different tools, right? I mean, there are so many tools in the market. For example, Excel, you would have seen, right? You would have seen maybe say Power BI, Tableau, right? I mean, the number of tools are basically endless. So every company is now developing its own tool. You can also build your own tool, right? But there are some open source tools which people use. And because they are open source and free, and if the community is so big, so you should also learn these open source tools, right? Venkat, you need to learn both SQL and NoSQL. SQL works with relational databases. NoSQL works with MongoDB. And there are some other tools on which, see, think about this. Let's say I ask you this, okay? You say a yes or no, okay, in return. Let's say you make a Python program, or let's say you make a C program. Can you tell me on which compilers you have run a C program? At least those of you who are from a computer science background. If you have ever written a C code, on what type of compiler have you run this C code? Sigma is not a compiler. So let's say you write a C program. What is TCDC? I don't know. Turbo C, is it Turbo C? Okay, Turbo C is one compiler. Okay, what else? Have you used any other compiler to run your C programs? GCC is what, right? GNU C compiler, right? Yeah, no, I'm not calling IDE. I'm asking you about the compilers. So think about, see, to run a C program, you have used multiple different softwares, right? Dev C++ is another compiler, right? So see, MinGW is an environment which provides you the compiler GCC. Okay. Yeah, Borland C++ is another compiler that you use. So many of you are giving me different names, right? I'm not talking about IDE here. I'm just talking about the compilers. Now think about this. Okay. The question is, if you write your C program, okay, and you want to get the output of your C program, can I use any of these compilers? Think about this. Can I use any of these compilers? Do you think that different compilers will give me different results? Is there a chance? So think about this. I mean, the same thing is here, right? The underlying language, which is SQL, okay, it stays the same. But the way these softwares are built, they are different. Some of them, they give you graphical interface. Some of them, they only give you command line interface. So depending on the kind of employees that you have in your organization is going to decide which software to go with. Okay. Maybe if they have money, or maybe if they need some special security, they are going to buy their RDBMS from Oracle. Okay. There are companies like Teradata which are building their own RDBMS. Okay. So you get the same results, right? So the underlying language, which is SQL, okay, it's the same across everybody. Okay. But it's on your company to decide like which tool to pick. Okay, so we are going to teach you SQL and show you the working on one particular software. Okay, today I'm going to show you MySQL. Okay, all right. Similarly, MongoDB is a tool for unstructured. Okay, or you can call it semi-structured. There are other tools for semi-structured also. So depending on like what your company uses, you can go with that. Okay, but the underlying language stays the same. It's no SQL. Okay. The session is recorded. I think you'll get the recording as well. I'm not sure though. Okay. This can be answered by a GUVI people. All right. I'm a co-host. I cannot start the recording. Okay. All right. Okay. Let's talk about what else a data engineer needs to learn. Okay. See, even though you have seen, I mean, I've talked about some of these tools which are for structured and unstructured. You need to, or a data scientist has to learn a few other things. Okay. So see, you need to have a good command on one of the programming languages. Okay. Now, which programming language to choose? So in the data science curriculum that GUVI runs, they have chosen that particular language which is preferred by most. I would say more than 90% of the users, they prefer that language. Okay. Which is called as Python. So you need to understand one of the high-level programming languages. Okay, the other commonly used language is R, but the number of users for R are very small. Okay, I would say only just 5%, very, very limited in comparison to Python. Now, what are the advantages that you get with Python? Okay, so first of all, it's also very English-like. Okay, the syntax is small. Okay, you don't have to write a large number of instructions to do a very simple task, unlike in C and C++. Okay. Now, most of the packages are readily available. I mean, every data structure is pre-built for you. So what you have to do is just import a specific package and do your, write 2 to 3 lines, and it will do the job for you. With minimal number of instructions, you can do anything pertaining to data science. Okay. I'll show you today. You can do a lot of things by writing 5 to 6 lines of code. Okay. All right. So, and obviously the community is so big. So if you're ever stuck somewhere, if you ever face any hurdle, if you face any error, just type on Google whatever would be the first search result, or maybe the first 2 results, they'll resolve your error. Okay, they'll give you enough hints. You'll be able to resolve your errors on your own. Okay. All right. Now, Sudhir, the session is on both. I'll talk about the machine learning practices also, but the session also talks about the roles of these roles of a data learning engineer. That's what I'm trying to explain. Okay. See, I can only do a limited number of things in the 2 hour slot. Okay. All right, but I'll try to accommodate all your requests. Okay. Let me come back to this. So now frequently used which can handle tabular data very, very easily. Okay. So unlike in SQL, where you are still restricted by a few things, okay, you can use pandas to gain more flexibility. I mean, you can write very, very intricate. I mean, you can do manipulations at a very, very granular level, which is not there in your SQL. Okay. In your SQL, you might have to write more lines of code to do a simple thing, but in your pandas, you can do it. So you can say it's very, very similar to SQL. Okay. All right. Sure. I'll do it, Sakala, don't worry. Okay. So what other libraries do? So there are some visualization libraries. So some visualization libraries like Seaborn, okay, Plotly, Matplotlib, okay. So these are very common. All right. Now, in addition to pandas, okay, you need to learn a few other libraries. For example, say NumPy. Okay, so NumPy is a library for, you can say, for working with your matrix kind of data. Okay, or your vectors, if you want to say it that way. Okay, then you have SciPy, which is predominantly used for statistics. See, if I describe like what a data scientist needs to know in terms of the theoretical concepts. So let me put it this way. There are 4 common areas which are common to both data engineers and data scientists. They need to know the theoretical concepts, okay, before they dive into the implementation part. Okay, so they need to know statistics. They need to know a bit of linear algebra. Okay, let me say basic calculus. Okay, basic calculus like differentiation, integration, some basics are needed. Okay, if I can say, in addition to linear algebra, let me say matrix algebra is also needed. Okay. See, linear algebra works with scalars like individual values. Matrix algebra works with matrices. Okay. You need to know some bit of probability theory. So concepts related to probability. And the final, the final domain I would say is optimization theory. Now, this is specific to machine learning only. Optimization theory is specific to ML only, because most of the machine learning algorithms that you will learn, okay, you can frame it as an optimization problem. When I say an optimization problem, you can say that you are trying to make a function which you want to either maximize or minimize. Okay, so it's an optimization problem that you want to optimize, let's say, in order to get to the maxima, or if you want to minimize, you want to get to the minimum. Okay, for that, you need to know optimization theory. So depending on the type of function that you write, there are different methods. So there is different maths for different types of maxima and minima functions. Okay, so in order to achieve maxima or minima, there are different algorithms to do it, depending on the type of optimization that you have, the type of function that you want to maximize or minimize. Okay, so optimization theory comes in there. All right. So Daksha is asking, see, Daksha, when I say statistics, I'm mentioning like an overview of it. You do have descriptive statistics, you do have prescriptive, you do have inferential. There are subdomains of statistics, okay? Yes, but what you have pointed out is exactly right. Not just descriptive statistics, they have to study the other types of statistics also, okay? I'm just telling you from a overview perspective. These are the domains a data engineer, also a data scientist, has to be well versed with. Okay. Yes, but you're right. Like they should know how to remove outliers, the spread of data, the skewness. Yes. Okay, I agree. But what you're mentioning is descriptive stats. I'm saying not just descriptive stats. Is linear algebra similar to linear equation? Linear algebra, you can say you do have a set of linear equations and you want to solve them. So if you use, linear equations, okay, you can put it in your, so I do not know whether you know this or not. So you would have heard of this Cramer's rule at least, right? So if you have, yes, so if you do have linear equations, you can use linear algebra to solve these linear equations. So that is one advantage that you get. But there are a lot of other things in linear algebra that you should know. One of the advantages that you definitely have is how to solve multiple linear equations with multiple variables. Okay. All right. Okay. Now, let me, if you are saying that if the data scientist has to be really good at calculus or he should be good at general maths, I would say that he doesn't have to be really great at calculus, but he should know if I give you a function, you should be able to simply differentiate that function and even double differentiate it. That part is expected. So given any function, you should know how to differentiate it. That is the least expectation I should have from a data scientist. Okay. So in terms of calculus, that is at least expected. So general calculus is expected. Okay. Simple integration and differentiation. When you study these topics in detail, you would definitely get better at general maths also. Okay. It's not that you will only touch derivatives and integrals. Okay. You'll be touching a lot of other things. So you will become good at maths if you try learning these topics one by one. So to learn, let's say one topic, you have to go through the prerequisites also, right? So let's say if I tell you, you have to be good at differentiation. Do you know that not all functions are differentiable? So how do you determine if a function is differentiable or not? If the function is not differentiable, then what should I do? So these things, you should know. Okay. And once you start diving into it, like why a function is not differentiable, what are the conditions for it to be differentiable, right? You'll get better at general maths also. Okay. So we are going to take you from, assuming that you are starting from scratch, we are going to take you to the very top. Okay. Varun, I'll answer your question at the very end. It's a generic question. It's a career-based question. We'll talk about it at the very end. Okay. Let me talk about how data scientists, okay, how the job of these data scientists differ from data engineers. See, so first of all, they do work in tandem. Okay. When data scientists are responsible for analyzing your data. Okay. So whatever data that you need, so what you will do is you will reach out to the data engineer of your firm. Okay. You will mention that I need this data because my manager has asked me to do some analysis and figure out certain insights. Okay. So you're going to contact your data engineer. What he'll do is he will go to the cloud-based services. Okay. He will collect all the data, pre-process it in the required format. See, imagine this. Let's say on these devices, which I've mentioned here. So when your data engineer is trying to retrieve the data, maybe one of them has stored the data in plain text. Okay, so it's, let's say, a .txt. Someone else has stored it in CSVs. Okay, so it's an Excel sheet. It's comma separated values, right? Somebody else has stored it in, let's say, .xls. Someone else has stored it in, let's say, .json. How do you merge all of it? And see, most of the times, data scientists, what they want is tables to work with. Okay. So how do you convert everything and put it into tables? Okay. Let's say somebody gives you images. Now images are of different size. So how do you ensure that, the tables that you give to your data scientists, they are of, they have the same representation for every image. They have the same representation for every text. Okay. So these things a data engineer needs to take care of. Now, see, for companies which are, which have been into existence for a small time. So unlike in Amazon and maybe say the big companies, okay, where where they have been established for a very long time, they do have a clear distinction about the responsibilities of a data scientist and a data engineer. So they want some specific roles some specific duties are there which are pre-designated. Okay, so a data engineer will do only this and a data scientist will do only this. There is a clear-cut distinction between the two. However, in early startups, okay, you would not get this distinction. So what they perhaps want, okay, so if you are applying as a data scientist, they might want you to, or a preferable quality would be, so you should also know how to work with cloud-based services. Okay, and I do think that's the reason why GUVI people also provide you with premium courses. So let's say if you enroll in the data science program, you can always do the data engineering program alongside. And if you enroll in the data engineering program, you can do the data science program alongside. And you do have access to, other tools. See, they do provide you premium courses alongside, right? So if you join GUVI, you will see that, okay? Oh, we have gone very much deeper into the session. I mean, we have been discussing for very long. Okay, so Mohit says, up to what depth do we need to know pandas? Yes, Mohit. The answer, unfortunately, is yes. You need to be well versed with pandas. Okay, I'll show you today. It doesn't take much time to learn pandas, maybe a couple of months, and if you have enough practice, you will become really, really good at it. Okay, all right. Okay, now I was telling you that there is no clear distinction in early startups. Okay, look at this. Okay, let me just get back to this 1 second. So there is no clear distinction between data engineers and data scientists in early startups. But let's say if you are clearly defining these responsibilities, what data scientists do additionally is the usage of machine learning algorithms. So data engineers are not involved with the application of machine learning algorithms onto your data. Okay, so for predictive analytics, these data scientists, they use machine learning algorithms to make predictions which can help your organization. Okay, for example, let's say if you have ever been onto any online website and you are trying to buy some product, you must have seen some recommendations, right? Let's say you are going to Netflix. When you watch a movie, don't you think it shows you certain suggestions? So how do these suggestions, how are these suggestions generated? They're generated through machine learning algorithms. Okay, think about this. When you're trying to buy an item, okay, you can think about, let's say, if I have the data about the purchases or the transactions of other users, can't I utilize this data to generate new recommendations for you? So maybe you have added an item to your cart, and I can actually look at what other users have bought. And if you have, let's say, item X in your cart, and if other users have also bought X, so in addition to X, whatever they have could be suggested to you. Okay, and how to come up with those? So there are tons of algorithms for it. Okay, not just one. Okay, there are some 7, 8 non-trivial algorithms. See, there are some things very, very trivial that you can do on your own. Okay, but there is a solid maths behind each of these algorithms that you're going to study in this main boot camp. Okay, for that, that's why I mentioned you need to be good with these 4 things. Okay, see, if you really want to become a good data scientist, I would say you have to be good at general maths also. Okay, but that comes with time. Okay, so one person is asking Power BI or Tableau, what should I learn? I should say learn both. Okay, I should say learn both, learn even Excel. Who's stopping you? Okay, Irfan, I don't know if you already work for a company or not. Okay, so these tools have a kind of, I would say, 50-50 distribution amongst different companies, almost a 50-50 distribution. Okay, personally, I know Power BI as well as Tableau. They're not very different. It's just that the GUIs are different. Okay, so it doesn't take much time. So you can learn both. Both are there, Pradeep. Both are there in the data science program. Okay, as far as I know, both are there. Anyways, okay. Coming back to so we have discussed about what characteristic distinguishes data scientists from data engineers. It's the usage of ML algorithms. Okay. Now, ML algorithms can be used for many, many different things. Okay, it's not just one. Okay, it's a whole domain in itself. Okay, it takes several months to master. Okay. Now, what are these machine learning engineers? See, So a machine learning engineer, you can say, is like the superset of data engineer, data scientists. And so machine learning engineer, if you draw the Venn diagram, see, if I draw the Venn diagram, so if these are data engineers and these are data scientists, machine learning engineer is actually kind of the superset. That's how I perceive it. Okay. So machine learning engineer knows the roles of both data engineers and data scientists. Okay. And also needs to know, how to do research. So if somehow you come across a new application for which no algorithm is out there, so you cannot simply take an existing algorithm because nothing exists. So how do you come up with, I would say, a new product altogether, a new application altogether? Okay, so a machine learning engineer is expected to be good at research also. So I would say, if you ever come across MLE opportunity, you would see that at least a master's would be required. You would never see, a bachelor's would be preferred for this job. If a bachelor is preferred, they would mention that they need to have at least 10 years of experience for it. Okay, so MLE is like, I would say, a higher tier job, which requires you to be really, really good at research, hence really, really good at maths. Okay, so they usually prefer, I would say, people who have, who have been graduates or doctorates, who have doctorates for it. So in general sense, MLEs are for doctorates only. That's what I would say. Okay. Rarely you would see a machine learning engineer to be a bachelor. If he or she is a bachelor, he would be really good at maths and will have at least 4 to 5 years of experience, the minimum. Okay. All right. Okay. So, okay. Charissa, are you there? Okay, guys. We are going to start with, say, MySQL. Okay, 1 second. So let me just show you a few tools which you can use to, pre-process your data, retrieve, edit, manipulate. Okay, and we are starting with the first one, which is your MySQL. Now, you can install this via pip. You can install this via apt-get. So let me just show you. See, if you just go online and if you type, okay, installing MySQL from scratch. Okay. So it will show you several links. Okay. Now it depends on which operating system you're using. So if you are using, let's say, Windows, executable is available online. Okay, you can go to this website, dev.mysql.com. You can download the executable. If you are on Linux like me, then you can install it through the command line. Okay, there is just one command that you have to run. Okay. All right. So if you want to access MySQL, the command to do that is, so you have to specify MySQL, and then you have to type -u, which and next to -u, you have to give the username. So -u stands for the user, and then you can specify -p. So -p is for the password. So if you click enter, I hope that the screen is visible to all. Okay, so if you click enter, then once again, let me see if I can. Wait a sec. No, that's okay. All right, just a second. Oh, my bad. Yeah. So if you see, it will let you in with this MySQL prompt. Kunal, please, can you not do it? Okay. So if you type, now you can start working with your relational tables. See, as it is a relational database, okay. So one thing that you could do is you can create your database. But before even starting with, let's say, databases, let me just show you what MySQL can do. Okay. So let's say you want to know what is your current MySQL version. So the command for that is select version. Okay. So now please note that any command that you type in SQL will end with a semicolon. Okay. If you don't use a semicolon, it will move to the next line. So let me just show you. Okay. So let's say I'm not typing a semicolon and I press enter. So it will carry on unless you provide a semicolon. So once you have entered the semicolon, it knows that the command has ended. Okay, and that's why it shows you right now that the current version of, SQL is 8.0, and this is the Ubuntu version that I have. Okay. All right. Now you can also look at the current date in case you want to know what the current date is. Okay. Okay. Uh, so please note that, guys, don't play, otherwise I'll kick you out of the session. Okay. Now, one thing you have to note is that, see, if you see this select, okay, it's a keyword. So if you have been building programs, you know what keywords are, right? They are some, you can say, some words which are used as, which are used for some functionality, right, for a particular language. So select is a keyword in this case. Okay, even current date is a keyword. You can use these keywords in any case. They could be in uppercase or lowercase. Okay, so even if I type, let's say, select current date, okay, this is going to work. Okay, keywords can be written in both uppercase or lowercase. All right. Okay. Now there is a popular keyword, let's say now, okay, which tells you both the time as well as the date. Okay. All right. Now SQL you can use as a calculator also. So let's say you are doing, let's say, simple basic calculations. Okay, let's say I want to compute, say, 4 into 5. Okay, so you can see that it has computed 4 into 5 as 20. Okay, you can use it as a basic calculator. You can even do some basic, say I want to do sine pi by 4. Okay, so if you want to do pi, so pi is there with a function. Okay, that's why you see functional brackets. Okay, and the word for sine is pi. So this is the value of 1 by root 2, okay, which is 0.7071 and so on. Okay, let me clear the screen for you. Just a second, I'll open the chart window also. Okay, Sudhir is asking, is select mandatory for every command? Sudhir, this select keyword is there, which tells you what is it that you want to print. Okay, so any SQL instruction is like this: select what do you want to print. Okay, okay, it would be like this. Okay, what do you want to print? Okay, you can replace this what do you want to print. Let's say you are working on a table, so it would be from which table. Okay, and if you have any constraints, so where, let's say, some constraints are satisfied. Okay, some constraint you will mention here where some constraint is satisfied. Okay, now I'm going to use this over and over. Okay, you will see that I'm going to use this instruction over and over. So the format would be select what is it that you want to print from which table, or say multiple tables, where you will, inside the where clause, you're going to specify which constraints that you want to satisfy. Okay. All right. All right. So let me start with some basic things. So see, as I told you that, we are working with databases, right? So we have to create a database first. So let's say I want to know beforehand if there is a database or not. So the command to show the existing databases is show. Okay. So this is how you can get the existing databases. If you install it by default, you will see these four, sorry. You will see these three and maybe SES. So if you install MySQL from default, you will see these four. The other two I have created. Okay. So let's say I want to create a new database. Okay. So let me tell you that the command to create a new database is create database and then the name of the database. So let me say that my database is new DB. Okay. And now I can show you that this database is now added here. Okay. You can see that this is now the new database. All right. Now, if I have created a new database, I now want to use this new database. Okay. So the command to do that is use. Okay. So now you can say that database is like a folder. So now you have gone inside this folder. So whatever you will do, the changes will be done to this folder, this new database only. Okay. Now, what is the first thing that you want to do on a database? Okay. Maybe you want to see if there are any tables inside it. Now, as of now, there are no tables, right? You can see that it shows empty set. So there are no tables as of now. So maybe let's say I want to create a new table. Just before that, there is one more thing. Let's say you have been doing MySQL for a long time, okay? And you want to know which database I'm using. So the command to do that is select database, okay? This will tell you which database you are in, okay? I hope this is clear. All right. So let us try to create a new table. Okay, can somebody tell me like what is it that you want to create? Think about, okay, let me create a table for you. Okay, let's say that I want to create a table for animals. Okay, maybe let's do it for pets. Okay, so the syntax to do that is, so first of all, see, when you want to create a table, imagine that you want to write, let's say, every row for one particular animal. So let's say that you own a dog, and say his characteristics are, so he would have a name, he or she would have a name, right? You would have the gender for it. Okay, so we want to store all this information inside a specific table. So let's try to create our first table. The syntax for that is, so create, table is the keyword, create is a keyword, and table is a keyword. Okay, and then we have whatever table that we want to create. Let's say I want to create this table pets. Okay, and now inside this table pets, maybe say I want to add the name of the pet. So name is the name of my column which I want to have. Now please note that for every characteristic that you want to store, you have to specify the type of it. Is it a string? Is it an integer? Is it a floating point number? Okay, so if you want to have it as a string, so you can put it as a varchar, which means variable number of characters. Okay, let's say the length of the characters is 20. Okay, so let's say we have one column in which we can enter up to a max of 20 characters. All right, 1 second. Okay, yeah, and let's say we now want to put the name of the owner also. So let's say the owner, and the name is again in varchar. Okay, let's say 20 characters. What else do you want? Okay, and because I'm using pets, so let's say I want to put species. So species you can also put as a varchar, let's say 10. Okay, maybe say sex. Okay, I'm going to put sex as a character. Okay, with one, so I will specify it as a male or a female. All right, and maybe let's say I want the birth date. Okay, so there is a type of you can say integer. Yeah, I can put the age also. So I mean, from birth date you can get I mean the date, right? So let me just say if this is bad. Okay, from birth date, what you can do is that uh, so I'm going to say that the birth date is stored as a date. Date is a type of you can say a data type, just like your floating point numbers and an integer. Let's say if or rather let me put, let's say, the death date as well. Okay, if the pet has died, or if that is still alive. Okay, from there you can compute the age, and let me just finish it with this. Okay, all right, so now you know that everything enters with a semicolon. Okay, so now you can see that the command has run. So the first thing that you want to do is, let's say you want to see if there are any tables which have been created, and now you can see that table pets has been created. Okay, and for this table pets, okay, now let's say I want to know, see, maybe some other table which has been created by someone else, right? I want to see what are the characteristics of this table. So for that, the keyword is describe, and you have to type the name of the table, and you will, sorry, 1 second. Oh, sorry, it is, I think, DESC. Yeah, the command is DESC, not describe. Okay, so you can see that there are six attributes: name, owner, species, sex, birth date, and death date. Two are of type date, one is of type character, the others are of type variable characters. We will discuss more on this, what are null, keys, default, extra. Okay, we will discuss more on this when we try to insert the values. Okay, all right. Okay, now see, what is it that you want? maybe you want to have, let's say, assume that you want to delete a new table. Okay, so the command to do that is drop, then which table do you want to delete? Okay, and you can say, okay, let me want to delete this table. So if I delete this table, then this table would be no more. Okay, you can just note down this command. I'm not going to run this. So you can, if you run this command, it will say that like one query executed and the table will be deleted. All right. Okay. All right. Let me just drop it directly. Okay. Or rather, let me just leave it. Okay. Now let's say I want to enter. So I want to enter some values into this table. Okay. So the command to do that is insert. So insert into. So this is the keyword insert and into. Now into which table do you want to insert? It was pets. Okay. And we want to insert some values into this table. Okay. So the if you remember the first, the first characteristic was the name of the pet. Let's say the name of the pet is say Sunny. Okay. The name of the owner is let's say Hari. Okay. Then the next thing was I think the type of the pet. Let's say it's a dog. Okay. Then the next thing was I think the gender. So let's say it's a male. Okay. The next thing was I think that birth date. Okay. So maybe say the birth date is. So please note that the birth date is given as year followed by your month followed by your day. Okay, this is the specific format for it. And let's say the pet is still alive, so I can put null here. Okay, the person, the dog hasn't died yet, so I'm going to put a null there, and then I'm ending with a semicolon. Okay, any doubt so far? So I can actually show you what is there in this table. Okay, so do you remember what is the syntax to print anything? So it is select. What do you want to select, right? So select star. Star indicates that I want to select everything. Okay, from which table? So select star from pets. I just want to run this. Okay, so you can see that there is now one particular row which is inserted into this table. So is this clear to everyone? Yes or no? Can you please type a yes or no? Okay. All right. So you can similarly insert as many as many rows that you want. Okay. Now, see, this must be very cumbersome for all, right? I mean, we have to write one instruction to add one row. So what you can do is, let me just show you a database. Okay. One second. Let me first show you a database. 1 second. Okay. Wait a second. So see, this is a file, and let's say I want to create many tables, right, in this in my database. Okay. So let's say I want to create a table classroom. So I have given the whole command inside this file. Similarly, I want to create a table department. I have given the whole command here, and I have given this command for table course. See, it's the same steps. Create table, table name. What is it that you want to insert? Table, the first characteristic of this table, the type of the course ID, the title, the type of title. Okay, department name, what is the type of department. Credits, so it's numeric with up to 2 integers. Okay. We will talk about this. This is called as a constraint. Okay. So you cannot enter a negative value here. That's what this means. Okay. We'll talk about this in more detail when we jump to the main bootcamp. Okay. And even we will talk about primary key and foreign key. Don't worry. Okay. So this is how you can, so whatever tables you want to create, you can write the commands in one single file. And let's say I want to run this. Okay. I want to run this. So what I can do is that, so let me first delete this table. And so if I show you, let's say show tables right now. So you will see that there is one table, right? So let me just delete this table first. And I'll show you that. So I have deleted everything. Let me show you. Okay. So there is nothing in my database as of now. All right. So I want to create those tables which are specified in this file. Let's say university ddl.txt. So I want to create this schema of these different tables. All right. So how you can do it is, so if you want to import any file, the keyword to do that is source. All right. And now you can mention where this file is located. So this file is located inside my home folder, inside this desktop, inside, I think, old semester. And inside this, I have university DDL. Let me just check what is the name of the file. University-ddl.txt. Okay, this is the name of the file. And you will see that once I click enter, it will say that, okay, query, okay, query, okay. So depending on how many instructions are there, it is running each instruction one by one, and then it gets executed. So can you take a look at this file and tell me how many tables will be created? See, this would create one table, which would be classroom. This would create another table, department. This would create another table, course. So 3, 4, 5. Yeah, you can also copy paste in MySQL. It's like copy pasting only, but now you have the command like in one single file. Okay. So you will see that we have a total of around 9 to 10 different tables in this file. Okay. If you need, I can send it to you and you can play, play around with it. Okay. So let me just show you, like it has now created many tables inside my database. So these are the tables which have been created. And if you want to see what are the characteristics of each table, okay, let's say I want to see what are the characteristics in my advisor. Oh, sorry, it's DESC. My bad. My bad. Sorry. Okay, so you can see that inside advisor, I have two different fields, SID and IID. Basically, it means student ID and instructor ID. So which student is taught by which instructor? Okay, the IDs of the student and the instructor. Okay, if I see more tables, I think there is one with classroom. Okay, so inside this classroom, you have building. So in which building the classroom is, the room number for the classroom, and what is the capacity of it. Okay, so let's say I want to now fill these. So Ramesh is asking, can you please repeat the source thing? See, Ramesh, if you type source, okay, and then you type the name of the file in which your SQL instructions are present, in which your SQL English-like instructions are present, it will run this. That is what the source means. Is it clear? Can you please type a yes or no? So let's say I type source and the path of the file, okay, and the path of the file, wherever the file is present in my system. And if I press a semicolon, it will execute all the instructions in this file, okay? All right. Please note that the syntax has to be correct. Otherwise, it is not going to run it. Okay, it will show you an error. Okay, let me just show you. So let's say if I write, select this, and let's say if I type this, do you think it will throw an error, or let me say, let me just write it like this. Let me simply say DEC and classroom. Yeah, you need to get the entire syntax correct, right? I mean, if there is a keyword error, it will throw an error, right? You can see that it throws an error because there is a S which is missing here. Okay, it has to be DESC classroom, right? So that way your syntax has to be, like totally appropriate. If you have ever written a program, you would know the importance of syntax, right? If syntax is not correct, your compiler is not going to generate the binary code for it. Okay. All right. Okay. Now, see, there are other ways to load the data as well. So let me just show you. Okay, 1 second. So let me say open a new file. Okay, 1 second. So let's say I have these. Let's say I have these. You can say entries. So let's say the first entry is Fluffy. Okay, which is the name of the dog. Okay, and then the next entry is the name of the owner. Let's say the name of the owner is, let's say Harold. Okay. The next entry is, let's say cat. So it's a cat. Okay. It's a female. Then you have the birth date. So let's say the date is 2020. So it's year followed by months, followed by date. Okay. And then you can type a \n to indicate that this is the new line. Okay. This is the new line. I'm forgetting we had a, sorry, \n is null, my bad. In this case, \N represents null. All right. Then you can have the other entry also. let's say I am having the second row as my, okay, one second. So let me just repeat this entry once. Let me just make some changes to it. Let's say this is GUVI, okay. And let me make it Henry, okay, just some random names. Okay, let's say this time it's a dog, okay, it's a male, okay. And okay, let's say this is the second row, and you can create as many rows as you want. Let me save this as a file. Let's say this is text, sorry, let me say it's data.txt. All right, let me save it onto my desktop. Okay, let's say I want to load this file. Now there are no instructions, right? So let's say I want to load this file inside my pets. I'm sorry, I cannot do it right now because I've deleted it, right? So if I show you the tables, there is no pets anymore, right? Unfortunately, I've deleted the pets. But the idea is this, okay? You can do this, okay? You can write load data, okay? And there is I mean, there are some special keywords involved, local data in file, and then you have the name of the file, which I now just created, which I called as data.txt. And then you can say into table pets. So this way it will load the data directly. You don't have to write those instructions like insert into table, and then you have to write these entries as Harold, cat, and so on. I hope this makes sense. Is it clear? How can you all agree that loading the data is very different from running the SQL instructions? Does it make sense? See, if you have any queries, you can just type. Okay, I will not be able to see the visible hands. Okay, so you have to give clear syntax, and please note that this syntax, this load data syntax, it's for loading the data. Okay, it's different from running a SQL file. It's different from running a instructions. Okay, this will load the data directly. All right. So I'm just going, see, because there is no table pets, so this will throw an error. Yeah, it's like updating your table. Okay. But you know that you can also do it with insert, right? All right. Okay. Now, let me add some values to it. So let me just show you. Okay. I have another data. I have a database with me. So I don't have to update each table one by one. Okay. Let me just show you. I have one table. One second. So see, these are the commands which I have for the university database. Okay, so you can see that if there is any table, so delete command is to delete a row. Okay, delete command is to delete a row. Okay, all right. Now you are trying to insert into values. So this is the first instruction which should be executed. So it will say that. So do you remember in classroom what was there? The building name, the building number, the classroom number and the capacity for it. So you are seeing the building name, the classroom number and the capacity. Let me just show you. Okay. So if I say describe classroom, okay. So you can see there are three things that it expects: building, room number, and capacity. Okay. So you can see that packet is the building, 101 is the room number, and 500 is the capacity for it. Okay. Please note that. See, uh, as of now, let me just show you. Okay. So let's say select star from your classroom. There is no such row right now. It doesn't contain any rows as of now. We have just created the schema for the table. It is like creating the header for the table. We have not added anything onto it. Okay. Now I want to add data into it. So I can again run this file. Okay. And this will add my data. Okay. So what I can do is source. I just have to mention the entire path. Okay, it's in old semester and I have, what's the name of it? It's university-data.txt. Okay. Okay, and now if I run this, it will run all these lines one by one. Okay, it will run all these lines one by one. Okay, so you can see that it is running all these lines one by one. If there was any error, it will show you that at that particular point in time, it stopped. Okay, so it is now adding your data onto these tables which we created. Okay. Okay, so now if I show you, let me put it this way. So let me show you. So let us see what the table names are once. Okay, and let me show you what is there in the classroom now. Okay. So now you see it has added some data, right? So if you look at this, so Packard 101-500, Painter 51410, look at these 5 rows. They have been added into classroom. Is this part clear? So we have added these values onto our classroom table. Okay. So in every table we have some values now. Okay. So let me just show you. Let's say select star from. Okay. Maybe say advisor. Okay, I want to see what is there in the advisor. So these are the advisor IDs. Maybe these are present sometime later. If you see some advisor entries are there. Yeah, these are the advisor entries. These are your advisor entries. Okay. All right. Now, so let me just show you advisor. Let's say I want to, instead of printing everything, okay, let's say I want only the student ID to be printed. I want this to be printed only. So what I have to do is I just have to write select SID. So I only need the student ID from advisor. See, this is very simple. It will now only print the student ID. So whatever you specify after select, which is to be printed, right? So that item will be printed. Any doubts here? Yes, people. Any doubts here? Okay, perfect. Let's say I want to, so let me just show you the table first. Okay. So let me say that I want to print, say the room number. Okay, so you just have to type select room number from classroom. So this is the room number that we have. Now imagine that I want to print all those room numbers where the capacity is say greater than 50. So I want to print all those room numbers. Basically, I want to print Packard. So I want to print, let's say, building and room number wherever the capacity is greater than 50. Okay, so Packard would come. Okay, then Taylor would come because the capacity is higher than 50. This Watson is not going to come, but this Watson will come, right? So let's say that I want to print, let me first print everything, okay? Select star from classroom where your capacity is, where your capacity is, let's say greater than 50, okay? So I'm printing everything first of all. So you can see that as of now, because it's greater than 50, even this is not coming, right? It's equal to 50, right? So if I say it is greater than equal to 50, then this will come. Okay. So then this Watson will come. Is this part clear? Yes, people. So you can get whatever you want. So let's say I just want my room number. So I only want those room numbers where the capacity is greater than 50. So you can see that you have three room numbers where the capacity is greater than 50. Okay. All right. So you can actually do a lot of things. All right. Okay, let me just put it like this. Okay, let me just show you a few other things. And with that, after that, I'll move on to pandas. Okay. Now, see, we are just touching this software. Okay. We are not going into the details. This is just the tip of it. Okay. So let me just show you like what all you can do with this. So let's say that I want to select the building names which start from or which end at the letter N. So I want to select all the building names. Okay, I want to select all the building names from this table classroom where the building, I mean, with the building name ends with, so the keyword for that is like. Okay, so I want to select everything. So you can have percent means anything can come. Okay, so let's say I want to select everything where this ends with N. So this means that I want to select all those buildings from this table classroom where the building ends with the letter N. And you will see that you only get N. Let's say I want to select everything which ends with the letter R. So you will see Painter and Taylor are coming. All right. Now let's say I want to select everything where you see, okay, let me just, where there is a letter Y in the middle, okay, where there is a letter Y somewhere in the middle. So can you tell me what would come? So percent is like an expression which you can fill with anything. So this would only Taylor would come. Okay, so percent Y percent means that anything which has a Y in between. Okay, and if you say like this, let me just put it. So if I say, let's say like this, so that starts with a T but ends with anything. So then you only get a Taylor. Okay, so there are some regular expressions that you can use. So I'm going to stop here now. This is just to show you the overview of SQL. You can actually merge multiple tables. So let me just show you like how you do it. Okay. So let's say that, so let me just show you two tables first. Okay, let me just show you two tables. Okay, let me first see which tables I should pick. Okay, so this is your classroom. Let's say this is your advisor. Let me see if, no, they don't have anything in common. Let me look at all the tables first. Okay, which two tables do you think will be related? Maybe say course and student. Let me just print those two. Okay, select star from student. Okay, so this is the ID and the name. And what is the other name of the table? Okay, I have, let's say, student I have done. Let me say instructor. Okay, select star from instructor. Okay, so you can see that these are the IDs of the instructor, and 1 second. These are the IDs of the instructor. And in the table student, you see the department name is there. Okay, so I want to get, let's say, here there is just the ID. I have to see teaches also. Okay, let me see. Okay, select star from teachers. Okay, we have the course ID, section ID. Yeah, now I have it. Okay, so look at these two tables. Okay, look at these two tables. Now I want to merge these two tables. Okay, can you tell me which two attributes can I combine? Look at these two tables. Can you tell me which two attributes can I combine here? Think about this. I want to merge these two tables. So course ID is common, right, between these two. So if I want to combine these two tables, I can, okay, let me do this. Okay, I want to print the course ID. Okay, I want to print only those course IDs where which are common to these two tables. Okay, teaches and course. Okay, which are common to this. Okay, so let me just put it this way. So let's say select. Okay, oh, sorry, select. So I want to print, let's say, the course ID itself. I have to see if course ID is capital or small. Okay, it's a small. Okay, so select course ID. Okay, from teaches and your instructor. It was instructor, right? Where select, yeah. So where your so now if you want to specify if course ID is coming from teaches, so you can say it like this: from teaches dot course ID is equal to your instructor dot course ID. So you want to see those rows. Okay, you want to see those course IDs which are common to teaches and instructor. All right, 1 second. Oh, the instructor doesn't have any course IDs. Which was the table name earlier? It was course. My bad. So this was course. Sorry, this is course. Course ID in field list is ambiguous. Wait a second. Okay, so I want to print which course ID. That's why it says it is ambiguous. I have to specify from which do I want to pick. So let's say I want to pick from teachers. Okay, So now you can see that these are the course IDs which are common to both the tables. Okay, you can do a little bit of more manipulation and figure out like if you want to join like multiple tables in one go with the help of some common fields. So let's say I want to do this. Okay, let me just put it this way. And okay, let me see if there is any additional thing that I can put. And I say that teaches.year is say 2009. Okay, and I'm putting one more constraint, and teaches.year is 2009. Okay, teaches.year is 2009. So you can see that now the number of courses have reduced because these are the courses that were taught in year 2009, and they are common to these two tables, teaches and course.